All right, my mathematicians, a new topic for today is percent of change. Sometimes it's called percent of increase because it may be an increase and sometimes it's a decrease. So sometimes it's called percent of decrease. So percent of change, percent of increase, and percent of decrease, they all mean the very same thing and you solve them the same way, which is good. The bad thing is some of you say you don't like formulas, but this is a quick, simple formula. A lot of people think about it like money, but it's not always money. Well, we're going to start with money because most of us understand money pretty well. So if we say an item started out at $20, and with inflation or whatever, the price changed to $25, this would be a percent of increase because it goes up. So the formula is change over original. So we want to know the original price or original amount always goes on the bottom. So the original is going to be 20. How much did it change? All we have to do is subtract these two numbers. And when we subtract those two numbers, we get 5. So I would do 5 divided by 20. And I get 0.25. Now, I need to turn that into a percent, and we worked on that last week, I believe it was. Move that decimal 2 times to the right, or you could have said that 0.25, remember percent means per 100 or out of 100. You could have times it by 100 and got 25%. Either way, it's the same concept. So change over original, that is our formula, and then turn it into a decimal. So here again, change over original. It's always going to be change over original we're looking for. This would also be a percent of increase because it goes up. So the original of 17 goes on the bottom. And then how much did it change? From 17 to 20, it changed 3. So our, in the calculator, we're going to do 3 divided by 17. Well, that gives me a whole lot of stuff I have to look at. I'm just going to write down the first 3. If I times that by 100 or move that decimal 2 times, that's 17.6. So if I round it, I like to round these to the whole number. That's usually what it's going to ask you to do. So that would be 18%. 18%. And again, that would be an increase. Now here we go from 36 to 20, so this time it's a decrease, but we still saw it the same way. If we look at change over original. So my original of 36 goes on the bottom. How much does it change? If we subtract these two numbers, we get 16. So we're going to punch in 16 divided by 36. And I get a whole bunch of 4s. I just write down the first 3 numbers just because I'm rounding to the nearest whole number. You can either times it by 100 or move that decimal 2 times. Either way, you're going to get the same thing. So that 4, with the last 4, there's a bunch of 4s there, that's going to be 44%. And if it asks, that would be a decrease. Most of the time it tells you in the problem, but that would be a decrease because it goes down. Okay? So now let's practice 2 little word problems. It says, in 5th grade, Kobe missed 8 days of school. In 6th grade, he missed 12. What is the percent of change? Well, we need to figure out, first of all, what is the original and what is the new. So obviously, whatever happened the earliest or first would be the original. So 5th grade comes before 6th grade. So 5th grade is going to be our original. So Kobe missed 8 days. Okay? And then in 6th grade, which is our new, would be 12. So our formula is still going to be change over original. So on the bottom, we're going to put 8. And the change is going to be the difference between the 8 and the 12, which is 4. So if you punch in 4 divided by 8 equals 0.5. Now, a lot of people do this backwards in their head and they'll say that's 2. They're really doing 8 divided by 4. So be careful and take a second and just punch it in so you don't make that careless mistake. So you can either say times 100 or move the decimal 2 times. If you move the decimal 2 times, you need to add a 0. So that is a 50% increase. So from 8 to 12 is an increase, so we would say that that was an increase of 50%. Okay? All right, one more. In the first game, Pedro scored 2 goals, and in the second game, he scored 3 goals. What is the percent of increase? We need the original, and we need the new. So whatever game came first is going to be the original, which was the 2 goals. And then in the next game, or the new game, he scored 3. So the new amount is going to be 3. Same formula, change over original. So the 2 is going to go on the bottom, and how much did it change? If you subtract those two numbers, you get 1. So if you want to punch in 1 divided by 2, you still got 0.5, same answer. That's just coincidental. They're not going to all be 50%. But that is going to be a 50% increase as well. So change over original and then go to a decimal. That's all you have to do.